Hello. Today I'll talk about the paper M-RewardBench, evaluating reward models in multilingual settings. In this work, we introduce a new benchmark for evaluating reward models in 23 diverse languages called M-RewardBench. By evaluating several RMs on Multilingual Reward Bench, we uncovered significant gaps in RM performance between English and non-English languages. But first, I want to talk about reward models. So, reward models are central to aligning LLMs with human objectives and values. It is often part of the RLHF pipeline, where we train a separate reward model and use that as a reward signal for fine tuning another model using RL techniques like PPO. And so, RMs actually act as the oracle that reflects preferred human values. We then utilize these RMs to steer models toward safety, reasoning, and instruction following capabilities. So there are several reward model benchmarks nowadays as our understanding of RMs improve. But at the time, Reward Bench is a popular and well-established benchmark that directly evaluates RM capabilities. Even so, Reward Bench primarily focuses on English and does not capture multilingual capabilities. And so we introduce M-Reward Bench. It is the first multilingual benchmark for RMs that tests their capabilities on chat, safety, translation, and reasoning capabilities across 23 languages. We attempt to make the language selection very diverse, including several high resource and low resource languages, different scripts, and linguistic families. So M-Reward Bench is open source and downloadable from Hugging Face, as you can see in the QR code in the slide. To build M-RewardBench, we start by curating instances from the English Reward Bench set and some translation instances from Maple. Then we perform multiple rounds of translation and curation. So we wanted to ensure data quality here. So we do three things. First, we use a high quality translator, in this case, Google Translate, and it's empirically shown to generate high quality translations for our dataset. And then we perform multiple rounds of human validation. So we filter out some cases that do not make sense when translated into a particular language. For example, there are coding questions that don't make sense when translated to Hindi, or some culturally specific questions. And finally, we perform multiple rounds of human validation to ensure that M-RewardBench aligns with native speakers. So in the end, our benchmark contains 66,787 instances for 23 languages. So this is also a parallel dataset. This allows us to perform straightforward comparisons across several languages, which is really good. To give you an instance of M-RewardBench, here's one from the Indonesian subset. So here we have a query where a user is playing a game called Into the Breach, and they're asking what does perfect information mean. So to give you some background, Into the Breach, it's a video game that's quite similar to Final Fantasy Tactics. You know, if that reference kind of like whooshed through you, just think of it like chess with guns and robots. So for a reward model to successfully answer this question, it should be able to assign a higher reward to the goal chosen response. So we follow M-Reward bench scoring based on accuracy. So we count the number of instances where the goal chosen response was rewarded higher than the rejected response. So in this case, we actually have different types of reward models, and as we've seen in literature, and I'll be explaining them more in the next slide. So we categorize these RMs into three. We have what we call classifier RMs. So these are models that take in a prompt and they output a scalar value. So what we do here is we pass both model responses to the classifier RM, then we get two scalar outputs, and the response with the higher score is the chosen response, while the other is the rejected response. And the goal here is that hopefully a good reward model will always assign a higher score to the chosen response. Second is a generative RM. Here we actually parse the actual text generations from a language model and use it as part of a feedback mechanism. So we adapted an empty bench LLM as a judge template so that it fits for multilingual text. So some of the changes we made was to kind of like incorporate the type of language or the source language in the instance so that at least the model knows where it is coming from. Finally, we also test implicit RMs, specifically reward models trained using direct preference optimization or DPO. So again, as a brief review, implicit RMs like DPO, they bypass the reward modeling stage by directly optimizing the policy model. So in this case, we don't literally have a separate reward model, but we do have a policy model that kind of acts as the reward model. So again, what we did is evaluate 20 or more diverse reward models, and I will share our findings in the next few slides. Um, I'll focus on four important findings in our study. We've definitely made a lot of important analysis in the paper, so I would definitely invite you to read more, and I'll share the links at the end. So first, we find that most reward models do well in English but not in other languages. On the left, we have a scatter plot where the x-axis is a model's performance on the English reward bench and the y-axis is their performance in the multilingual reward bench. Notice that most of the points are skewed towards the right, showing that although these models perform well in English, it doesn't generalize well to other languages. Moreover, we also pick some well-known models and check the delta in performance across different subsets, and it's shown in the table on the right. Here, we see that overall, even for models like GPT-4 Turbo, there is significant performance degradation all throughout these subsets. So again, there's definitely still a long way to go to improve RM performance on a diverse set of languages, and it's good that our benchmark allows us to track this progress further. Number two, we also find that RM performance is sensitive to translation quality. In this experiment, we prepared two versions of multilingual reward bench. One translated using NLLB 3.3 billion parameter model, and one translated using a higher quality translator, in this case, Google Translate. As you'll see in the line chart on the right, there is a performance increase when moving from NLLB to Google Translate, suggesting that hopefully more faithful translations can actually improve RM performance. I think this is a very important finding because this shows the relevance of ensuring that multilingual evals should be faithful to the actual usage of its speakers, and that in some ways it actually correlates well to RM performance. For our third finding, we also find that RMs in general, they tend to be biased towards certain linguistic dimensions. In the charts below, we divide the languages in the M-RewardBench subset into their resource availability, language family, and script. So if you look at the leftmost bar chart, we have the resource availability based on the language categorization from Joshi et al.'s paper. So the lower the number, the less resource a language is. Here we see that there is some correlation between a model's performance on M-RewardBench and the resource availability of that particular language. Sure, this is expected, but this goes to show that there is still a long way to go to ensure that RMs cater to under-resourced languages. For the middle and rightmost charts, we see that for some language families like Austronesian, Sino-Tibetan, and Indo-European, and some scripts like Latin and Cyrillic, reward models tend to perform better. Overall, I find this very interesting because it shows which languages or scripts need more work on reward modeling. And I hope this gives us a lot of insights on some targeted data collection practices that we can do if we want to improve reward modeling for multilingual NLP. Finally, we also look into the agreement of several RMs across several languages. We find that no model achieves complete agreement between other languages and English, while some exhibiting greater volatility across languages and other demonstrating more stability. We also observe that some of the highest performing models are not always the most consistent ones. For example, models like Gemma 2, its average performance surpasses that of Llama 370B. So you can compare it like it's a small parameter model versus a 70B model. However, the larger capacity model demonstrates greater consistency in labeling across languages. So this is a very important finding because we see that we're not just looking at like the accuracy of a model on M-RewardBench. You're also seeing if it's actually consistent, if its answers are actually consistent. And I think this is important if we wanted to look into using these models as kind of like an oracle for, like downstream RLHF training. So in the end, with Multilingual Reward Bench, we now have a parallel high-quality benchmark for multilingual RM evaluation, a leaderboard of multilingual RM performance for state-of-the-art RMs in literature, and hopefully a better understanding of reward model behavior in multilingual settings. So this is the last slide. Finally, I'd like to thank my collaborators, especially my co-first authors, Srishti, Shayak, and Rishab. I'd also like to thank my teammates Trishti and Gusti. And finally, I'd also like to thank our mentors Nathan, Sebastian, Sarah, and of course Marcia. This project was actually born from the IA expedition last year. It's like a hackathon, a 6-week hackathon from Cohere Labs. Personally, for me, it was an awesome experience, and I'm very happy that I've met several researchers who share the same goals and interests in multilingual NLP. Again, thank you for listening, and you can download the paper using the QR code to learn more about our work. Thank you so much. Have a great day.